Hey everyone. So today's topic is the difference between accuracy and precision. And the theme of the entire unit is taking measurements. So that's really what we're concerned with. Anytime we're taking measurements, whether you're doing a lab or if you're watching a demonstration, anything like that, we're wanting to make sure that our measurements are both accurate and precise. And so, in order to make sure that that happens, you have to know what is the difference between the two. What is accuracy? What is precision? And how are they different? All right, because we want to make sure that we have both. So, between the two, accuracy is how close you are to the actual measurement. So, if there's an amount of substance, let's say the actual volume is 5 milliliters, then if you were to measure the volume of that object and it was, say, maybe you came up with, let's say, 20 milliliters, 20 milliliters versus 5 milliliters, that's not very accurate. All right. So accuracy is how close you can get to the actual measurement. Precision is how closely or how well you can repeat the actual, or how closely you can repeat taking measurements. All right. So let's say you measure the volume one time and it's 20 milliliters. The next time you measure, it's 21 milliliters. The next time you measure, it's 19 and a half milliliters. All right. Those are measurements that are close together. All right. So those would be precise measurements. And when we're talking about equipment, we're gonna look at using equipment and look at the precision of equipment tomorrow. But when you're using equipment, precision of an piece of equipment tells us how small of an increment we can measure with that piece of equipment. So to go back and review those two definitions, accuracy is how close you are to the correct answer. Precision is how well you're able to measure and get the same measurement repeated attempts. So with a piece of equipment, as far as precision goes, the smaller the increments, the easier it's going to be to get that same measurement over and over. All right, using different pieces of equipment. So this here, we have a target and we have all of the X's right there in what is the bullseye. All right, this right here is both accurate and precise. We see when we look at the X's, they're all in the bullseye. Every single one of those X's is accurate. That's accuracy. When we look at each of the X's, they're so close together that we say that would be a precise measurement. We're able to closely repeat that same measurement. If we're to look at this one, we see the X's are not in the bullseye. The X's are up above, so we would say that that's not accurate, but the X's are still close together, so the X's are precise. We're able to repeat the same measurement multiple times. So this would be precise but not accurate. Okay, this one here, we have all the X's right there around the bullseye. We would say we've hit the bullseye every single time. There's a part of the X in that bullseye, but those X's are spread out. So this one here, we were going for the bullseye, so it was accurate because we hit the bullseye each time. But since they're spread out, we would say that they're not precise. And then the last example, again, we're going for that bullseye. We don't hit the bullseye with any of them, so they're not accurate. And then they're so spread out, they're spread out more than any of these others. So we would say that this one here is not accurate and it is not precise. All right? So that's the difference between accuracy and precision. So here, let's look at this lab procedure. So we've collected data, and for each piece of data, we're going to figure out is the data accurate? And we're going to figure out is the data precise? Right? So for this lab, there were a bunch of groups of students, and each student group was taking measurements, and they were using a balance, triple beam balance. They tested, and the actual weight, the correct answer, is 5.01 grams. All right, so remember that, 5.01 grams, and they measured for each group. All right, so group number one, they did 3 trials. All right, group A, using balance A, they measured 4.98. Then they measured again and got 5.01. They measured a third time, got 5.00. So is that accurate? The actual measurement is 5.01, and all 3 of their attempts were pretty spot on. It was one time they got the actual weight, and looking at the rest of the data on the table, they're the only ones that got the actual mass of that object. All right, so yes, it is accurate. Is it precise? Are all the measurements close together? Yeah, for the most part. I mean, they were off by 0.03, 0.3 of a gram on their first measurement. So yeah, that's precise. So group A was both accurate and precise. Group B had measurements of 4.05, 3.98, and 4.00. These were way off from the actual weight or actual mass. So no, it's not accurate. Is it precise? Yeah, they're pretty close together. So yeah, we would say that these measurements are precise. Group C, we have measurements of 3.57, 6.04, and 4.59. All right. Are these accurate? They're pretty far off. So, no, they're not accurate. Are they precise? No, they're spread out. So, these measurements are not accurate. They are not precise. And then our last group, 5.09, 4.72, 4.99. All right, are they accurate? Remember that the actual mass is 5.01. Here, yeah, they're pretty close to the actual mass. So we would say that yes, those measurements are accurate. Are they precise? All right, we have 5.09, 4.72, 4.99. So compared to some of them, yeah, they're precise. Compared to Group A, they're not as precise as Group A, because Group A, they were only 3/100ths of a gram away from the actual answer. All right. Here with Group D, we had, what was it? 0.28, 0.37. So 37/100ths of a gram off. So compared to group A, no, these results are not precise. All right, we were over a quarter of a gram different from trial 1 and trial 2. All right. So we'll get into a little deeper tomorrow, or with the video tomorrow, the demonstration, as far as the precision of lab equipment. But I'm gonna talk about it real quick here. So we're looking at our ability to repeat the same answer. All right, not necessarily the correct answer, but the ability to repeat the same measurement over and over and over again. All right. The easiest way, or the best way to do that, is by using a piece of equipment that is precise. So when we're looking at the precision of a piece of equipment, we're looking at how small are the increments on that piece of equipment. Can we repeat? So if I'm using 3 different pieces of equipment, a beaker, a graduated cylinder, and an Erlenmeyer flask, am I able to use all 3 of those and get the same measurement using all 3? That would be precision. All right. So, and as we'll see tomorrow, there are some pieces of equipment that will be more precise than others. So some will have smaller increments, and the smaller the increment on that piece of equipment, the more precise the equipment is. And the easier it is for us to repeat that same measurement. So if I'm trying to measure the volume of a liquid to 1/10 of a milliliter, then there are some pieces of equipment that just won't let me do that because they're not precise enough. They don't have small enough increments that separate the different measurements. So here we can see that on these two scales, the increments are different between the two scales. So this one over here, the difference between this line and this line, the numbered lines, is we have a measure of 10. Let's say that this is a graduated cylinder. So if these are increments of 10 between 20 and 30, each of these lines is worth 1 milliliter. All right. So if we're using this graduated cylinder, we can measure out a liquid, and our measurement would be precise to the milliliter. All right. So we could say 21 milliliters is right here, 20 milliliters right here. This one over here is different. We see the numbering, instead of going from 20 to 30, the numbers go 20, 21, 22. So this one breaks it down. Instead of going increments of 1 milliliter, each of these lines is 2/10 of a milliliter. We see that between here and here, 20 and 21, we have 1, 2, 3, 4 lines. So each of these is worth 2/10 of a milliliter. So here, we can only measure difference in 1 milliliter. Over here, it's a difference of 0.2. So if I needed to measure a liquid to the 1/10 of a milliliter, I would use this graduated cylinder instead of this one. Because over here, I would have to estimate. All right? We don't want to have to estimate it if we don't have to. We need to get as close as we can. All right, so when we look at these two pieces of equipment, think about which one is more precise. Over here, the beaker, we have lines in depending on the size of the beaker. The one that I have in the demonstration for tomorrow is a 500 milliliter beaker, and it goes in increments of 50 milliliters. While the graduated cylinder over here, we see every numbered line is another 5 milliliters. So 1, 2, 3, 4, 5. So each line is 1 milliliter versus 50 milliliters over here. Which one's more precise? Yeah, it's the graduated cylinder. All right. So that's the difference between accuracy and precision. Accuracy is how close can you get to the actual answer, the correct measurement, and then precision is how well can you repeat the measurement that you've taken. And how precise is the equipment? How small are the increments? The smaller the increments, the easier it is to get the same measurement using different pieces of equipment. Right? If I use this graduated cylinder for 3 different trials, and each trial I have to measure out 8 milliliters of water, I know I've got 8 milliliters of water using the graduated cylinder. With the beaker, I don't know. I have to estimate. We don't want to estimate if we don't have to. All right. That's all that I have for you today. If you need any help, you know how to reach me. And we'll see you next time. Have a great day.